Hello and welcome to the final session of 2018 for the DBA Fundamentals Virtual Group. I am Glenda and we are talking today with one of our sponsors, dbWatch. And our speaker today is Per Undheim. I'm really excited about listening to cross-querying multiple SQL sources using Xpath-based queries. So we'll dive into that in just a minute. Other organizers here today as well are Steve, Shane, Kevin, and myself. Without our sponsors, we wouldn't be able to provide all this amazing content. So we're going to take just a second to recognize both of them. Our first one is SentryOne, and we do a lot with them. They actually have quite a bit online, SQLperformance.com, a lot of blogs, videos, free downloads, things like that. You can also ask for free query tuning advice at answers.sqlperformance.com. Check them out online and let them know we sent you. Our second sponsor tonight is actually here today speaking with us. Let's see if I can get there we go. dbWatch, and I'm really excited to listen to them. We haven't had a chance to look at all of their products yet, but we're going to make sure that we get early next year or so a full walkthrough so we can give you some more information. But they're a full platform management solution, including licensing and security and performance, and as well as administration and monitoring ports. So definitely give them a look-see, and you'll see more, and you'll hear more, I should say, from them later on, just a few minutes. Regarding our specific virtual group, again, our organizers, Shane, Steve, Kevin, and myself, those are our Twitter handles. You can get a hold of us if you need us. You can also make sure that you're following us, the virtual group, on Twitter at DBA Fun. We make sure we tweet out about these sessions about a week, a day, and an hour before or so, as well as afterwards when the session is then available on the YouTube channel. Our YouTube channel has about 4 years worth of sessions, so you can check them out check us out at dbafuntube.org. Also, if you haven't already, you can register on the PASS website and subscribe to our email list. We send an email on Mondays, and it has a list of all of the upcoming session for that week, as well as all of them for the future as well. Lastly, our Slack channel. If you haven't gone into Slack, it's a great community. They have a lot of different channels. We actually specifically have the DBA Fundamentals channel as well. Upcoming SQL Saturdays, again, this is towards the end of the year, and actually these are already gone, but January 12th has Nashville. So check out SQLSaturday.com and look for an event near you. There are some already registered for 2019, so check them out. It is a wonderful way of getting some free training and also a lot of networking. I have met a lot of different people just by showing up at SQL Saturdays. So you are, of course, in the database fundamentals virtual group, but there are many virtual groups in PASS. This just shows you business intelligence, there's PowerShell, professional development, performance, there's a lot. So a couple we highlight normally are Women in Technology and the Saturday Night SQL. Check them out. It's an awesome way of getting some more content as well. Upcoming virtual group webinars, of course, ours today. Women in Technology has one tomorrow, Introduction to Azure Search. The Global Hebrew, Global Italian, another Women in Technologies. And then we have one in January as well for Plan Stability through Plan Forcing with Aaron Stellato. All of them you can check out at thepass.org and look through as well. Lastly, we like to keep these short before we get to the speaker. This session will be recorded, so you'll be able to look at it through the DBA Fundamentals YouTube channel, which is going to be dbafuntube.org, and also in our meeting archive on the PASS website. With that, I'm going to go ahead and turn it over to our speaker, and let me make you a presenter, and we'll let Per and his wonderful accent give us the presentation.
Okay, let me see.
Yep, perfect.
Yeah, perfect. Okay. Welcome to this DBA Fundamentals presentation. My name is Per Christopher Undheim, and I work as a Senior DBA at dbWatch, where I mostly work with R&D related to SQL Server and Oracle platforms. Today, I will talk about the benefits of using an Xpath-based query language to create cross queries on top of SQL sources. This is quite an advanced topic where I will introduce some new concepts, so make sure you have a cup of coffee at hand. But although it's a lot of new concepts to take in, I will show quite a few examples to make it easier to understand. If we want to know anything about the database instances we have, we need to query the databases. And for this use case, I have 4 database instances: Manda, Silos, Cecid, and Tatooine. They are all SQL Server database instances. And 4 is not that many database instances to manage. And what I want to know today is how many user sessions are connected to each database instance. And to do that, I need to run a SQL query. And I have a query I want to run that counts up the number of user sessions they have. It's highlighted here in orange, and it's my favorite SQL Server counting sessions, but not the background sessions and task manager query. So I run this query on each database instance, and then the result of the queries has to be copied from my SQL query output and pasted into an Excel spreadsheet for analysis. And you will end up with something like this. And I think this is something most DBAs do on a regular basis. It's quite straightforward and easy. But when you don't do it all the time, and you have just 4 instances to manage, it takes not a lot of your time, but it's boring and it's repetitive. And sometimes you might have other database platforms you need to report on as well. Like when you still have some reluctant Oracle instances you haven't been able to remove yet, like Tanab here, or your query is not compatible across different versions of the same database platform. And there could be cases when you have some SQL service on-premise and some new databases in Azure. And I think this is the reality in many places. And often when I work as a DBA in the past, I got responsibility not only for the database platforms I knew pretty well, such as SQL Server or Oracle, but also some platforms I hardly knew at the time, such as MySQL and Sybase. They were left over from some old piece of software, and I hoped I never needed to fix them. But I still needed to report on them and make sure that they didn't stop working. What you end up then is multiple queries you have to run, one on some instances and others on the rest. And you need to keep track on what query should be run on which instance. And in this case, I only have SQL Server and Oracle, but it's still 2 different queries. They do exactly the same thing. They count users sessions, but not background sessions from the database instance. And for each metric we want to look at, there is a new query. We have 2 different queries for instance name and 2 different queries for session count that we looked at earlier, and 2 different queries for disk usage, and then 2 different queries for memory usage. So only when we look at these simple metrics, the instance name, the session count, the disk usage, and memory usage, and we have 2 platforms, we end up with 8 queries we need to maintain and understand and use to query the data we need. And we need to pick up the right one to run at that instance. So we need to know the instances we manage quite well already. And that can be a problem in itself, as we will look into later. But I think most DBAs have a long list of SQL statements that they use to gather different bits of information from the database instances they manage. And when you get bored of the manual job of running the query, copying and pasting the results, you start looking for ways to avoid this manual labor. So maybe you make them into a view or join them together, so at least you don't have to run all the queries independently. And you end up with something like this. It's our 4 metrics for each database platforms, joined together, or maybe more like stitched together. But this has a drawback too. As a DBA, you will likely end up with many of these nice to have but very complicated queries. And I have spent many hours looking for the comma that was missing, or the single quote that turned into a backtick, or the parenthesis that went missing. You might also turn it into a script, but it's very inflexible. So when someone asks you for a new metric, you have to dive into old code with a lot of complex queries to sort out. So when we find a good query, wouldn't it be nice if we could create an alias for each of these queries? So when we need the result of that query, you can just ask for the alias instead of having to merge and join difficult queries together. Say we give the name of the instance query the alias name, the query behind session count, the alias total session count, the query for disk usage, the alias disk usage, and the memory usage, query the alias memory usage. So this way, at least when we have found the right query, it stays right. And if we need to correct it, it's just a simple query that can be easily understood. So imagine just running this simple query on each database instance, just querying the alias and having the alias automatically resolve the different queries for the different platforms and versions. Wouldn't that be a good idea? So this is a 42 database instances. And for me, this is around the time where I don't feel I have a strong personal relationship with each and every one of them. I might know a few, and it's usually the ones that causes problems. And only by the powers of scripts and Excel, I will know the IP, the version, the session count from last week, and the disk usage some time ago, and the memory usage from the last time I checked it. It's sort of in control some of the time, but not always, and not when it needs to be. So then you turn into 170 database instances, and this is a fairly normal amount of database instances to keep track of for one DBA. But scripts and Excel will now only keep my head partially above water. It's mostly an exercise in diving into the wreck of an instance, trying to fix the most important things before running to the next. And I think it's the life of many DBAs. This is what an environment of 1,200 database instances looks like in PowerPoint. It's like a white blob of things. If you are in healthcare or work as a service provider, this is probably your reality, with multiple platforms and versions. And when I started off as a DBA, the 4 databases we had in the start of this presentation was the databases I had to handle. But now we are moving towards more data and more database instances and other data sources as well, because the role of a DBA is moving in the direction of managing data in general. And if this is not your reality today, in 5 years' time, this will be a normal size of a database instance estate. And maybe it's me that's a bit lazy or a bit forgetful, but long before I would reach this size of environment, I would have forgotten the name of the database instances or their version or the platform, and the simple but repetitive task of querying each database instance, then to copy and paste the results into an Excel sheet sounds like labor camp. And I think that with some of the data, such as the number of sessions connected to the database instance, also, the results from querying the first database instance is outdated by the time I reach the last. So what about that good idea we had earlier? If we could somehow find a way to structure the alias so that even environments like this can be queried and reported on. But to really be able to work efficiently when we need to query multiple sources, we need to put a query language on top of the aliases. And today I will look at our implementation of such a concept and how that works. There is a natural way of structuring these aliases. Some concepts like memory usage or total session count have a single value that's associated with that instance. But other concepts like agent jobs is a list where each element of the list has a set of properties. This results in a structure similar to the directory structure used to organize files on a disk, or the tree-like structure of an XML document. An Xpath is a language created for transformation of XML documents and works well for these kind of queries. Each of the node is a result of a SQL query. So in the case of total session count, there is the same SQL query I used manually on the 4 instances, but when this is defined as a node in the Xpath structure, instead of running it manually on each database instance, it's queryable as a value of a property in the Xpath tree structure. We define this in XML as a property which has a key and a value. And the key here is total session count. To limit queries to run only on the database type that this query works on, it has a compatibility tag. In itself is a query on different properties, in this case the database type. This allows a given property key to have multiple definitions so that each database type might get their own SQL query. So now the problem we had earlier, where we needed to remember to run the right queries on the right database platforms and version, is taken care of. And this is a very important part of how this can function on multiple database platforms and versions. Compatibility allows for multiple queries to gather the same type of data from multiple sources. Any property can be a compatibility tag, so you could make another property definition later based on the total session count, so that the property only would run on database instances with more than 100 sessions connected, for example. Then we have the value definition, and this is what will give the property key, the total session count, its value. It says we use a SQL engine to run, and it's a SQL statement, just like the one we run in SQL worksheet. And the last parameter, valid for, this is a cache hint. It's how long its value is valid for before we start a new SQL query to get fresh data. Here it's set to 1 minute, since the information about how many user sessions that are connected to the database instance, it changes quite rapidly. But for other queries that are heavy and doesn't change that often, maybe a valid for of 24 hours is the correct setting. This parameter is important to offload the database instances when you have data that needs to be queried frequently. Xpath queries is somewhat similar to a directory path. It's a bit like directories and files. If we want to get a value, we type the path and the value is returned to us. We start off with a simple query. We ask for the name of the instance. This is a similar query in Xpath as when we did the individual SQL statements and put it into Excel. We just write instance/name and we get the value for that property, name, for each instance. In the background, the SQL statements for the name properties run on each instance, and the answer is cached. So if we should query this again in the near future, we don't have to query directly to the database. Then we can add column formatting, so that the column that used to be called name is instead formatted as database instance. This is often also used in SQL statements when we want to give the column headers a better name. Now we add a new concept, anchoring. This is a reference pointer that allows us to join two properties together. The instance node is anchored in the I variable. And this allows us to start from the same node item each time we query a subnode or child node in the tree. We'll use this in the next step when we add a column to the query. So here we use $i. to refer to the same instance element again when we query the value for total session count, formatted as session count. Now we have joined two properties in such a way that both the value for database instance name and the value for session count refers to the same database instance. If we didn't use this to connect the two properties, it would just be two columns that were not connected and could have a name for one instance, but the session count value for another instance. But since we use an anchor, we open the possibility to query multiple values at once, starting from the same node item. For instance, if we want to add disk usage value displayed alongside with database instance name and session count. This allows us to put information together from many different queries into one result set. Now we added disk usage alongside in the query, and we get a view that contains multiple key metrics for a database instance. And now we have something that could solve our initial problem of querying and merging data from multiple database instances using different aliases. It is in fact a bit like how a data warehouse works, where multiple queries extract data, transform them to connect together, and allows you to query on top of that data. But using Xpath and the caching engine, it's now on the fly in real time, and it's easy. So every time you have a new alias you want to create, it's just a few lines of code in a file, and new items can be queried across your database instances. But even though we mostly talk about SQL queries, this can also take input from other sources as well. As we see in the definition of our query in the property definition, the type of engine was set to SQL. The reason for this is not to limit this functionality to SQL queries only. Maybe you have information located elsewhere that needs to be added into the view. It could be that the information is located on the host machine itself, or maybe on a web server. Or it could be that a mix of data is needed to be put together. And sometimes the information you get from your query is not formatted correctly for the value you want to give the property. Then a processing engine is needed. So this flexible query structure enables multiple engine definitions where one engine can feed data into another. For query engines such as SQL, SSH, or other Xpath queries that feed the data into processing engines like regex or JavaScript. And we will look into a few examples of what that looks like. Here we have an example that uses SSH to query the host of a database instance for its hostname. And the only major change from the SQL property is now that the compatibility is for the type OS type Linux, and that the engine name is now SSH. And the query is now a command that is executed by the shell on the database instance server. And we can add an even more advanced example. This uses SSH shell commands, where the output is then passed to another engine, in this case the regex engine, as input. This is a waterfall type model where the engine line on top feeds data to the engine line underneath, and the queries are run in order, the same order they have in the definition. Then the structure of a node and its child nodes are defined from the result of this regex. And multiple engines can be combined to create advanced properties that merge information together. It's also possible to add programming logic into this, where a JavaScript run routine processes data that is gathered by other queries. One SQL query that selects a text, URL text, from a table called URL info in the database dbWatch. This is given an outscope, which is a reference name that predefines it as a variable in JavaScript. And we get a string from an Xpath query into a property called metadata underscore URL string. And this is given the outscope string to find. Both of them then are used in the JavaScript routine that downloads the contents of a web page, checks for a string, and then the result of which is processed in an if-else logic to set the property value accordingly. And there's many benefits from multiple sources and post-processing. And one important benefit is integration with organizational data. Most companies have a lot of data about the systems they manage. This data can be in many different locations and sources. And when you export this data again for reporting and maybe into Excel, it's enriched with information such as customer name, database location, SLA requirements, or link to other documentations. So now we have other data to enrich our queries. We can add a new column, and this time we add the property of location. This is an example of a property we get from different sources than the SQL database itself. Of course, we can run this query and then copy and paste the data into Excel, but maybe we can do something a bit more clever. Let's export this data as a web page, one that is dynamic and refreshes the query data every time we refresh it. So we can take our query and define it as a web page. It is the same query used earlier, but now it's mapped to a URL called myQuery on the local web server. And suddenly we have the result of the query available, automatically exported in many formats such as XML, HTML, CSV, and JSON. But we use the CSV output in this example because it's easy to integrate with Excel. So I see that we could have skipped the column header format for this query, as CSV output will strip that data off anyway. The data here will be refreshed every time we reload the web page, and depending on the cache settings, also queried from the database instances directly. When we have a CSV data available as a web page, it's very easy to integrate this straight into Excel as an external web data source, where we can see the output from the query we run. It just works with the default settings in Excel, and it's very easy. Took me 5 clicks and 1 paste. And now we're back with our data in Excel. But this time it's not a copy and paste routine where we run our SQL statements manually. It's automatically updated data straight into our Excel sheet. And we also have the added bonus of other data, such as the location of the instance, added into the result set. So let's try another use case to see how powerful this method can be. This is around 170 database instances. It's a fairly normal amount of databases to manage. And I need to know if any of these database instances has a performance problem right now, without waiting for the users to call me. By the way, this method would work just as fine if we were managing 1,000 instances or 50, but it just happened to be the size of the environment I tested on. So the scenario is that I want to find out if I have a performance issue, and I need to look into any and all of the database instances right now. And the most interesting metric for this view is waits. If we know what each of the database instances is waiting for, we know where we should put in our efforts. So we define a property that gathers the waits that are created and sort it in the top 5 wait types for that instance, based on some underlying historical table for the database. And then an Xpath query is put on top of the properties generated, and the data is merged from the database state. What we want here is some sort of graphical representation of the output data, marked in red. So we give a hint to the query engine what we want this data to be rendered as a bar type of graphic, where the value of 100 is max, and with a warning threshold of 85 and an alarm threshold of 95. We also give a new hint of sorting so that the table output is sorted. And what we can expect to get is a table output where we have the name of the database instance, the platform info, which is database platform type and version, the host name this database is running on, and a graphical bar representing the current waits total for this instance, where the database instance with the most waits is sorted on top. Furthermore, we will know the type of weight that is ranked as weight A for the weight type with the highest amount of weights, followed by a new bar that displays how much of the total wait time of the database instance this weight type represents. In the same way, we also get the second and third weight type and its corresponding amount of wait time. And the last variables is the average weight for this instance at this time of day, and indication of weight types that have been excluded from the underlying query, and the name of the server that this database instance is connected through. And we get something like this, where we merge data about the database instance name and platform data all into one view. And it's now obvious what database instance is struggling and where we need to channel our efforts. It's clearly two database instances that are struggling at the moment out of the 170 database instances we are managing. And in the same case, we might want to know not just when a disk is full, but how is every disk on all my database instances looking right now? If there is a lot of disks that is near full, maybe it's time to start ordering more drives or plan for more disk use in the future. Knowing not only when you have an immediate problem, but always being able to take the pulse of your database instance state is very useful when you want to stay in control and not be caught off guard. So this is a view on top of a set of properties where we gather different disk sizes and used percent. And we query this in the same way as the weights view and display the first 6 drives on the machine. And this is an example of how useful that can be. This is an overview of all the disks on all the database instances and how full they are. It's a bird's eye view where it's easy to see that individual disks are filling up, or you can get an impression of how much of the signed disks is nearing full. This is a report that is time consuming to create without this way of distributed queries. Of course, you might have monitoring that alerts you when the disk is full, but that's a more reactive approach. This is proactive approach. Always knowing how much of your disks you are using always allows you to fix any upcoming problem before you get an alert. And this is a maintenance job overview. So running automated maintenance of your database instances will stop many problems to occur. And it's a good way to work proactively. I think most DBAs have some set of jobs or scripts that they would like to run. But knowing that they actually run on all the database instances, and if they have found an error or needs manual intervention, it's usually not that easy to handle. And this is an example of how it can be handled. All the maintenance jobs and their status for all the database instances put together. So now it's easy to see that the dbcc checkdb job has found a problem, or if there is tables that need reorganization. And this works just as well on all of the database versions you might have, both on and off premise, and also for the jobs you run in Azure. It doesn't have to be a table output either. This data can be fed into other types of output, such as graphs and dashboards. And you can create custom dashboards for sets of database instances so that customers or key account managers can get an overview of their databases and their databases only. So it's a quick summary. I think Xpath solves many of the problems that are found in managing database instance state, especially if you have a complex environment with multiple database platforms and versions, or when you have a lot of database instances to manage and need to work as efficient as possible. Xpath enables us to create queries that are easy to read and maintain. And we can create overviews with unique insight that are very hard to create using other methods. We can combine the information from multiple sources, even sources that are just loosely connected with the database instances. We can use this to integrate the information from the databases with other systems, such as Excel. And we can hide and handle technical differences between different database platforms and versions. And the result is a unique functionality that is key when managing heterogeneous database estates. There is a lot of other ways to use this type of concept as well, such as creating monitoring that checks data from Xpath queries, maybe comparing data from multiple database instances, Or you can use this to take data from different database types and maybe merge it together before you put it into another database. Or you could build PDF or HTML reports or custom dashboards on top of the data. For instance, if you want to automate reporting on data from a set of databases, that could be on different platforms. And if you found this interesting and want to try it out on your own, the software used to implement this is available from http://download-dbwatch.com/download/latest. And it's free to use for test purposes on 3 database instances without a license key. Or if you want to test on larger environments, you can email us at support@dbwatch.com. I know there is a lot of difficult concepts in this workshop. So if you have questions that you only want to ask me directly, my email is per@dbwatch.com, but I'm also open for questions.
Well, Per, I think we did really well on questions. First, make sure to say I found the entire presentation extremely interesting. I know I'll be trying to use Xpath more in the future anyway than I have been currently. Actually, there were no questions by our group. So do you have any final thoughts, Sir Bear?
Yeah, I think it's one of the reasons that we don't get questions right after this presentation is because there's a lot of concepts are new here. It's another way of looking at the entire database environment and the data you are managing, and it puts you on top of all the databases, all the data sources you have, and so it's kind of lifts the DBA work up one level, to put it that way. So you can manage how the data is moving around the company, really.
Is there any specific gotchas, like this is usually where I mess up, that you're aware of anyway? Or do you just...
Well, it takes a bit of time to get into because it's a different, as a DBA, you're used to SQL queries and how they are organized. And it takes a bit to getting used to another way of querying. So there is a lot of query examples on the wiki page so that people can see other types of queries. And yeah, it's an uphill learning curve, I think.
Very much so. It is not for the faint of heart either.
That's true, but it's once you get into it, it's a very powerful way of taking hold of your data and giving it to other parts of the organization, or to move data between databases, or to structure how you see the information. And it's sometimes it's the queries we make is limited by the experience we have, so that we don't think that this way of seeing data is possible or easy to do. So we find that a lot of when we do development or create dashboards of view for customers, it's hard to ask what they want because they are not used to knowing that it's possible.
Okay. We actually did get a question. For those reports you showed, did you only use Xpath in Excel, or did you use the dbWatch product to actually generate those?
It uses, let's see, when we get to the reports, this uses the dbWatch product. So when we do the Xpath queries, this is our implementation of it. So to run the Xpath queries, you need dbWatch.
That makes sense. Okay.
So when we do the queries, this type of queries, you have to run that through dbWatch.
Okay. All right. So do you have any information you'd like to share about dbWatch itself?
Let's move to the last page. Well, it's really easy to get into, and you don't have to start querying with Xpath to begin with. All the views you see inside the product, well, most of them at least, is created in Xpath itself. So yeah, so it's easy to install and set up. It takes 5-10 minutes to get it running, and you can download it without registering. So it's easy to try out.
Awesome. I know you're obviously the main page we get here for dbWatch information is the Wikipedia page.
Oh yeah, so of course there's lots of the Wikipedia page is for documentation, but there is just www.dbwatch.com for more presentation of the product, to put it that way.
All right. Yeah, those three web pages you show on the screen there seem to be the most important ones that we need to at least get started.
Yeah.
All right. Well, cool. Okay. One other question we actually got in. Are the alarms only available through the app, or sorry, let me reverse that. Are in the app are only alarms available, or can you also use emails, pagers?
Oh yeah, in the product, we have something called extensions, where it's predefined outputs to other monitoring solutions like SCOM or to email, which you can set up, or SMS gateways, or HP OpenView, or different platforms. And there is also a command line client that you can use to integrate, and there is REST APIs you can use to query, and yeah, so it's a lot of possibilities.
Really, can you use it with PowerShell then?
Well, there is a command line client that you can integrate into scripts that will run all the Xpath queries, or you can export the Xpath queries as a web page. So you can either run it interactively with a command line client, or you can use it through the application itself, or you can use it when you query the web server product as well. So there's multiple ways to use them queries.
Awesome. Sounds very good. Well, I do thank you, Per, for showing all this. It has been extremely informative. I know I'll be at least downloading the product to try and use Xpath as much as possible, or at least begin using Xpath. And so with that, do you have any final thoughts to give our viewers?
Yeah, well, if anyone tries it out and they have any problems, they could either contact me directly on my email, or you can email support@dbwatch.com. We support even customers that are not customers, but want to test it out and just generally get a feel of the product.
All right, then. Thank you so much. And with that, we have the session is now done. So everybody can drop off. Thank you all so much.
Thank you.
Everyone have a great day.